In this video I will walk through the nansen.setup procedure. It might be a good idea to watch the video on the Nansen application first, because it will show you where we want to end up. Before starting the Nansen setup, I just want to show quickly how my data is organized on my hard drive, because the main aim of the setup is to create a model of the data and to link the data to different sessions. On my hard drive I have a folder called raw data, and here I have two folders, one called microscope data and one called rig data. These two folders contain data from the different recording systems that I'm using. As you can see, all the data is organized by date, and for the microscope data it's organized first by date and then by session, so each folder here is a session recording. For the rig data it's a little bit different. For each date folder, inside there's different mouse folders, and again inside a mouse folder there are different session folders. I also have a data folder called processed, where some processed data for these sessions exist. So now we will run Nansen setup, and one of the main goals of Nansen setup is to create a model for how this data is organized. We'll also do a few other things. For example, we'll install some toolboxes, either required or optional, and we will create a metadata table for the existing data. So the first step is to download toolboxes, and I've already gone through this, but there are a list of available toolboxes here. So you can see for me I have already downloaded and installed all of them. Some of them are marked as required and others are optional. The next step is to create a project. The idea of the project name is that it should be short, and it needs to be a valid MATLAB variable. It's going to be used for creating a MATLAB package. So I will call my project demo, and I will save it to my desktop. It might be a good idea to save the project to a cloud location, for example Dropbox or Google Drive. The project folder won't contain much data and it won't take a lot of space, but it will be nice to have a backup of it, and also useful if you're analyzing data across computers, because then you can access it from multiple places. The next step is to add data locations, and a data location is a location on a hard drive which contains some data. The default setup is to have two data locations, one for raw data and one for processed data. As I showed you, I also have a third data location which is for raw data that comes from my rig. So I'm gonna add that. I can also mark my raw data as 2P, coming from a two-photon microscope. I select the data type, so there are different options here. The recorded data type just has some stricter access level, so you cannot write data to a recorded data location. And then I will select the root directory where my data is located. So I select the root location for my microscope data, and the process data is filled automatically, but in this case I want to place it slightly differently. So I want to select the folder I have, which is processed. And then lastly I enter the data location for my raw data rig. In the next step we will define the subfolder organization of each of the data locations. So for my raw data 2 photon, I have first in this list a subfolder level which shows the different subfolder which contains a date. This is a subfolder type of date, And in the table on the right, it shows a list of all the folders that are detected. I can now add a different or a new subfolder level. We see that the list is updated with the folders that are under the date folder. And as I said before, this is a session folder. Now we can see there's a lot of stuff here that actually I don't want, and it's possible to do filtering operations on the folders. So for example, there's some reference images, there's a surface image, there's some rotation alignment images, and all of these are not really sessions, it's just smaller recording I did. So I can add these in my exclusion list, and note that I added on the second line because all of this is subfolders on the second level. And when I press enter, the list is updated. And then we can look, there's one having something called aborted, I just add that. Something called failed, and I will also show now a different way to do filtering. So now I added things to exclude, but I can also add things to include. And what we can see is that all my sessions have a specific type of session ID. And it always consists of a mouse ID and then a date and then a time. So if I now enter M, and then each number is replaced by the number symbol. So now it filtered the list down quite well. Let's do one additional step. I'm gonna add 4 more numbers. So now my list is pretty clean. I can do the same for the 2 different data locations. The process is already pre-configured, and this is the default way to organize process data. First, it's organized in an animal folder and then a session folder. And the last thing is the raw data rig. In this case, we have a date folder, and then we have a mouse folder, animal folder, and then we have a session folder, and then we have a folder of another type, and lastly we have a new folder of another type. Okay, now I can move on to the next page. And the idea here is to configure how to get some information from the session table. So if you saw the video with the Nansen application, you saw that the sessions are organized in a session table. And some of the variables in that session table is animal ID and session ID, and also experiment date and time. And in many cases it's possible to find these values from the folder naming. And that's what we want to do here. So based on the selection of folder types, it already guessed that the session ID can be found from this folder name. But for the animal ID, we also select that folder, and for the experiment time, we select that folder. And now to determine which part is the animal ID, I go to this button and I click select substring. And this lets me select which part of the folder name is the animal ID. In this case, it's these 4 letters, and I use shift to do multiple selection. And now we see that it found the animal ID of this session. So I do the same for the session ID. Starts with the animal ID and it ends with the session date and time. And also I add the string which is at the end. Now the thing about my sessions is that all of the session IDs are not the same length. So I can briefly change that by, instead of saying going from 19 to 50, I will go to the end. Then it catches everything until the end. And now I select for the date, here I can just select everything, but I have to specify what kind of format so that MATLAB can convert this into a date. And for me, the string is first year, and then underscore month, and then underscore day. So we see that it identified the right date here. And now I can do the same for time. So the time is located here. So I now select only the numbers, and I have to then set the time as hours, minutes, and seconds. And as long as my folders are named consistently, this should now be identified correctly for all the folders. In the last step of the setup, we want to configure data variables. Now, each session of a two-photon experiment contains different variables that all are common across sessions. For example, we have two-photon data, and we have ROIs. And we also have ROI signals. And each of these are represented by their own variables. And usually they are located either in one or multiple files. Now we want to link each of these data variables to the file where we would find them. We'll start with the two-photon series original. And we have to make sure that it's that we find it in the right data location. And now we can open the folder of this data location for this session. Now, the file containing the two-photon raw data is this one, which is called .raw. We also see that this has this XYT pattern in the file name. And we can use that to uniquely identify all the two-photon series that are time series recordings. So we can enter XYT in the file name expression, and we can select .raw. In this case, every file which matches this pattern can be referenced using the variable name two-photon series original. We should also change the file adapter. In this case, we want to use a file adapter called SciScan2p series. For all of the other variables, unless you already have processed data, we just want to keep the default settings. So basically, if you now have a raw recording, we can access the raw data from the variable two-photon series original, and we can run motion correction on that. The motion correction would then output a two-photon series corrected. And when we later draw ROIs, that would be outputted to the ROIs variables, and the same with ROI signals. Now last, I want to just show how you can add a custom variable. And in this case, we have to show all variables, and then we are able to add new variables using the plus button. I'm going to add a couple of variables from my raw data rig. And if I open the raw data rig folder, we can explore what variables are there. There's a lot of files, but one of the files that I could use in my project is the pupil video. So I go back here and I give it a name, which I call pupil video, and I enter pupil video in the file name expression, because all my pupil video files have this part in their file name. And this was a .raw file, and it can be opened using the ImageSec file adapter. I can add another file. And I want to add a file which is called setup data TDMS. This is a file containing data which is recorded from my DAC. And I would call it DAC data. And I enter setup data in the file name expression. Maybe that wasn't correct. I have to set the raw data rig. And then I enter the setup data. It should update the available file types. This is a .tdms file. We see now that there is no available file adapter for opening this file. And that's something that we can create later. For now, I wanted just to show this as an example. So now we press next one final time, and we create a session table based on the configurations we made. And here we go. Now we have a list of all the sessions that were detected on the hard drive. And this is where the fun begins. Now we can start making session methods. And we can interact more with the data using the available GUIs that we have.